Cool. So, been avoiding this just because it's just another one, But I have my final project in my Java class coming up, and as I've said in videos before, I just don't really get along with the way that my teacher teaches. So it's better if I teach myself. So here we go. I'm gonna do this Learn Java course, and then I'm gonna do the Intermediate Java course, and then hopefully by then I'll be able to uh, to pass my final flying colors. So, Introduction to Java. Welcome to the world of Java programming. Programming languages enable humans to write. I get it. Okay, I'll read it. Programming languages enable humans to write instructions that a computer can perform. With precise instructions, computers coordinate applications and systems that run the modern world. Sun Microsystems released the Java programming language in 1995. Java is known for being simple, portable, secure, and robust. Though it was released over 20 years ago, Java remains one of the most popular programming languages today. One reason people love Java is the Java Virtual Machine, which ensures the same Java code can be run on different operating systems and platforms. Sun Microsystems' slogan for Java was, "Write once, run everywhere." Here we see a Java program, class hello world, public static void main string args, system out, print line, hello world. Goes through a compiler, can run it on Unix with JVM, run it on Windows API with JVM, and run it on macOS with JVM. Programming languages are composed of syntax, the specific instructions which Java understands. We write syntax in files to create programs, which are executed by the computer to perform the desired task. Let's start with the universal greeting for a programming language. We'll explore the syntax in the next exercise. You're looking at a computer program written in Java. Run the code in the text editor to see what is printed to the screen. Hello world. Hello Java file. Java runs on different platforms, but programmers write it the same way. Let's explore some rules for writing Java. In the last exercise, we saw the file hello world.java. Java files have a .java extension. Some programs are one file, others are hundreds of files. Inside hello world.java, we had a class. Public class hello world. We'll talk about classes more in the future, but for now think of them as a single concept. The hello world concept is hello world printer. Other class concepts could be bicycle or savings account. We mark the domain of this concept using curly braces. Syntax inside the curly braces is part of the class. Each file has one primary class named after the file. Our class name, hello world, and our file name, hello world. Every word is capitalized. Inside the class, we had a main method which lists our program tasks. Public static void main string args. Like classes, we used curly braces to mark the beginning and end of a method. Public static and void are syntax we'll learn about in future lessons. String brackets args is a placeholder for information we want to pass into our program. This syntax is necessary for the program to run, but more advanced than we need to explore at the moment. Our program also displayed the text hello world on the screen. This was accomplished using a print statement, system.out.println hello world. We'll learn more about print statements in the next exercise. So the text editor has a file hello-u.java that contains a hello-u class with a main method. Inside main, add a statement which prints hello some name with your name replacing some name. So system.out println hello geo. The semicolon. Cool. Print statements. Okay, I'm gonna zoom by some of this stuff, because I already know the basics. But I'm just, I don't want to skip to the intermediate. I want to refresh my memory on the basics. So inside main and underneath the print statement, system.out.println, let's play hide and seek. Output the following two statements using system.out.print. Ugh, the semicolons. This is why I hate Java. This is a big part. And also, it's just like, just make it print. You know, why I gotta do this. This is why I like Python. I'm learning Swift at the same time. I like Swift. It's simple. Underneath your previous statements, I'll put the following two text values using system.out.println one, and then ready or not, here I come. Even C++ is just, there's something about it. I have a love affair with it. It's not as simple as Python, but it's like respectable, but not aesthetically displeasing in the way that I find Java. But unfortunately, the places I want to work use Java, so I must use Java or work somewhere else. You know, we'll see what happens with that. Once again, the semicolon, my dreaded foe. Up next, what do we got? Commenting code. So, the file timeline.java has plain text information about Java. Plain text facts aren't valid syntax. We'll use comments to avoid breaking the program. Use the single line comment syntax for the first fact. Change this line into a comment. Sun Microsystems announced the release of Java in 1995. Program is still broken. Use the multi-line syntax to make these lines into a single comment. James Gosselin is a Canadian engineer who created Java while working at Sun Microsystems. His favorite number is the square root of 2. Okay, hold on one second. Cool. Sorry about that. So, where was I? Still working here? I believe we are. Right? Oh, yeah. Yeah. Okay. So, semicolons and white space. Yeah. The language facts.java file prints information about Java to the screen. Unfortunately, the writer of the file has avoided using white space. Make the file easier to read by adding a new line after each statement. So when it says new line, it just means inside main, add a new statement printing out how you feel about coding. Start the message with programming is. System.out .println programming is interesting. Gosh, I can't do the one thing it wants me to do. Let's get it right. Compilation, catching errors. Java is a compiled programming language, meaning the code we write in a Java file is transformed into bytecode by a compiler before it is executed by the Java virtual machine on your computer. A compiler is a program that translates human-friendly programming languages into other programming languages that computers can execute. Previous exercises have automatically compiled and run the files for you. Off-platform development environments can also compile and run files for you, but it's important to understand this aspect of Java development, so we'll do it ourselves. The compiling process catches mistakes before the computer runs our code. The Java compiler runs a series of checks while it transforms the code. Code that does not pass these checks will not be compiled. This exercise will use an interactive terminal. Codecademy has a lesson on the command line if you'd like to learn more. For example, with a file called plankton.java, we could compile it with the terminal command javac plankton.java. A successful compilation produces a .class file, plankton.class, that we execute with the terminal command java plankton. An unsuccessful compilation produces a list of errors. No .class file is made until the errors are corrected and the compile command is run again. Let's practice compiling and executing a file by entering commands in the terminal. Our text editor contains a broken program, so we can see how compilers help us catch mistakes. Don't make any corrections. In the terminal, type this command, javac compiling.java, and press enter or return. You will see an error message, but don't worry, we will resolve it in the next step. Click the check work button to check your work and move on to the next checkpoint. Do you see the error? The compiler is telling us one of the print statements is missing a semicolon. In the terminal, type ls and press return or enter. ls is short for list, and this command lists all the available files. There's only one file, compiling.java. We did not successfully compile the file because of the error. Click the check work button to move on to the next checkpoint. Add the missing semicolon in the text editor, then click the check work button. We'll compile and execute this file in the next exercise. Compilation, creating executables. Compilation helped us catch an error. Now that we've corrected the file, let's walk through a successful compilation. As a reminder, we can compile a .java file from the terminal with the command javac whales.java. If the file compiles successfully, this command produces an executable class, filename.class. Executable means we can run this program from the terminal. We run the executable with the command java whales. Note that we leave off the .class part of the file name. Here's a compilation cycle as an example. Within the file welcome.java, we have one file, welcome.java. We compile with the command javac welcome.java. Terminal shows no errors, which indicates a successful compilation. We now have two files, welcome.java, our original file with Java syntax, welcome.class, our compiled file with Java bytecode, ready to be executed by the Java virtual machine. We can execute the compiled class with the command java welcome. The following is printed to the screen. Welcome to Codecademy's Java course. Let's compile and execute our program. Run the ls command in the terminal to see the uncompiled Java file, press check work, compile the file from the terminal. So Java C compiling.java, check work, enter ls, check work, enter ls, run the executable file from the terminal, then press check work. So Java compiling. Java is a class-based language. Java classes have a main method. Java statements end with a semicolon. Programming is fun. On to the next. Java review, putting it all together. In this lesson, we've started writing our first programs in Java. We've also learned rules and guidelines for how to write Java programs. Java programs have at least one class and one main method. Each class represents one real-world idea. The main method runs the tasks of the program. Java comments add helpful context to human readers. Java has white spaces, curly braces, and semicolons. White spaces for humans to read code easily. Curly braces mark the scope of a class and method. Semicolons mark the end of a statement. Java is a compiled language. Compiling catches mistakes in our code. Compilers transform code into an executable class. The text editor holds an empty file named review.java. Fill it in. Define a public class named review. Use opening and curly braces for the scope of the class. Remember, no semicolons for classes or methods. This code produces an error because Java programs need a main method. Define the main method within the curly braces of the review class. So public static void main string args. Inside of the curly braces for the main method, write the main method executes the tasks of the class as a single line comment. So single line comment will have below the comment, write a statement that prints the following. So system.out.println, my first Java program from scratch. Semicolon. It's annoying. Okay, cool. Up next. Little quiz, probably. No, an article. Java program structure. Java programs have a specific structure. Let's take a closer look at the Hello World program line by line. Java programs have a specific structure in how the code is written. There are key elements that all Java programs share. The program. We have the text of a program inside the file called helloworld.java. This program outputs the message hello world to the monitor. This program writes hello world to your terminal when run, and we see public class hello world, curly braces, public static void main string args, curly braces, system.out.println hello world. Case sensitivity. Java is a case-sensitive language. Case sensitivity means that syntax, the words our computer understands, must match the case. For example, the Java command for outputting text to the screen is system.out.println. If you were to type lowercase s system.out.println or uppercase system.uppercase out.println, the compiler would not know that your intention was to use system or out as intended. Let's go over this hello world.java program line by line. So we have comments, simple enough. Classes, this is the class of the file. All Java programs are made of at least one class. The class name must match the file. Our file is hello world.java and our class is hello world. We capitalize every word, a style known as Pascal case. Java variables and methods are named in a similar style called camel case, where every word after the first is capitalized. The curly braces, and so those mark the scope of the class. Everything inside the curly braces is part of the class. Methods, public static void main string args. Every Java program must have a method called main. A method is a sequence of tasks for the computer to execute. This main method holds all of the instructions for our program. Statements, system.out.println hello world. This code uses the print This code uses the method printLine to send the text hello world to the terminal as output. PrintLine comes from an object called out, which is responsible for various types of output. Objects are packages of state and behavior, and they're often modeled on real-world things. Out is located within system, which is another object responsible for representing our computer within the program. We can access parts of an object with a dot, which is known as dot notation. This line of code is a statement because it performs a single task. Statements always conclude with a semicolon. Whitespace. Java programs allow judicious use of whitespace, tabs, spaces, new lines to create code that is easier to read. The compiler ignores whitespace, but humans need it. Use whitespace to indent and separate lines of code. Whitespace increases the readability of your code. Practice. The structure of a Java program will feel familiar the more you work with this language. Continue learning at Codecademy, and you'll be a Java pro in no time. Following code will run without an error. Public class language facts. Public static void main string args, and I already see that there's no semicolon, so this is false. In Java, what is the purpose of leaving comments in code? They're only present in compile. Nope. They are how words. Nope. They provide human readable notes that clarify thinking. It's true. What will the following code print to the screen? Hello Cody. Let's see. Does it contain an error? Public class hello you. Public static void main string args. System.out.println hello Cody. What would the name of the file be if it contained the following code? Hello world.java. Java is a compiled language, meaning the code we write is translated by another program into a language the computer understands. It's true. Comment the code with the correct syntax. What is missing from this Java program? Public class language facts, the main method, public static void main string args. Cool. Let me, planting a tree. No thank you. I would not like to do this. It's just all the simple stuff, right? Which I already know. It's fine. If you want to plant a tree, you can go plant a tree. I will not be planting a tree. So let's just move on to the next. What is an IDE? Learn about the integrated development environment, an application that makes programming easier. So, basic stuff, editing source code, syntax highlighting, autocomplete. So building executable seems Java specific here. Java is a compiled language before programs run. The source code of a .java file must be transformed into an executable.class by the compiler. Once compiled, the program can be run from the terminal. This compilation process is necessary for every program, so why not have the IDE do it for us? IDEs provide automated build processes for languages, so the act of compiling and executing code is abstracted away. Like in Codecademy lessons, debugging. No programmer avoids writing bugs in programs with errors when a program does not run correctly. IDEs provide debugging tools that allow programmers to examine different variables and inspect their code in a deliberate way. IDEs also provide hints while coding to prevent errors before compilation. The biggest benefit to using an IDE is that it allows you to code and run Java programs on your own computer. We recommend IntelliJ IDEA, which you can download for Mac OS, Windows, or Linux. You should download and install Java to your computer before using an IDE. I'm VS Code gang, except when I use Xcode, which is recent, but mainly VS Code. Now we have a new section. Before I get into this, I'm going to go heat up some more coffee. Be right back. Just gonna check to make sure this is all working as intended. Do I have any text? Oh, I have mad text. Hold on 1 second. 1 2 1 2. I don't understand why OBS loves to glitch out like this. I know something is wrong whenever I see it like this. Yeah, something is very wrong. The microphone's still working. The webcam is being weird. If I X out of this, it's gonna stop the stream. I think I'll just have to do a new stream, cause I don't. If I edit it as it is right now, it's gonna mess it up in the future. I guess I genuinely don't know if this stops the stream or if I can open this back up and still be streaming. I assume it will, so this is probably gonna stop. 1 2 1 2. So it gave me an option that said resume interrupted stream. I don't know right now if this is a new video or the same video. I hope it's the same. But regardless, where was I? Come back here. Don't need to worry about that. Back here. Alright. So, back to Java with my cold coffee. Introduction. Let's say we need a program that connects a user with new jobs. We need the user's name, their salary, and their employment status. All of these pieces of information are stored in our program. We store information in variables, named locations in memory. Naming a piece of information allows us to use that name later, accessing the information we stored. Variables also give context and meaning to the data we're storing. The value 42 could be someone's age, a weight in pounds, or the number of orders placed. With the name, we know the value 42 is age, weight in pounds, or num orders placed. In Java, we specify the type of information we're storing. Primitive data types are types of data built into the Java system. The three main primitive types we'll cover are int, double, and boolean. This lesson will introduce these built-in types and more. We must declare a variable to reference it within our program. Declaring a variable requires that we specify the type and name. So the pattern is data type variable name. So int age, double salary requirement, boolean is employed. The names of the variables above are okay, I get it. So in creator.java, we have defined some variables related to James Gosling, the creator of Java. Inside main, use systemout.println to print out the variable name. Use the same command to print out year created. Ints. The first type of data we will store is the whole number. Whole numbers are very common in programming. You often see them used to store ages or maximum sizes or the number of times some code has been run, among many other uses. In Java, whole numbers are stored in the int primitive data type. So I get it. The file count comment.java has a number of comments in it. In your head, count the number of comments. Then inside the main method, declare a variable named numComments. So int numComments holds how many comments you counted. 1 2 3 4 5 6. Print out numComments. Doubles. As of 2016, Android has 81.7% of the market share for mobile operating systems. Create a variable called Android share. Booleans. Create a variable called ints can hold decimals. And then print it out. Yeah. decimals. Char. Fill it out with a single letter representing the grade you think you would get in a graded Java course where the grades A, B, C, D, and F are possible. You already know what it is. Print out your expected grade variable. String. Create a variable called opening lyrics. Why is string capital? Does it say here? So, string objects. Maybe because really behind the scenes, a string is just an array of characters. So you're really calling it, yeah. There are two ways to create a string object: using a string literal or calling the string class to create a new string object. A string literal is any sequence of characters enclosed in double quotes. Like primitive type variables, we declare a string variable by specifying the type first. String greeting equals hello world. We could also create a new string object by calling the string class when declaring a string like so. There are subtle differences in behavior depending on whether you create a string using a string literal or a new string object. We'll dive into those later, but for now, we'll almost always be using string literals. Keep reading AP Computer Science A students. Certain symbols known as escape sequences have an alternative use in Java print statements. Escape sequences are interpreted differently by the compiler than other characters. Escape characters begin with the character backslash. There are 3 escape sequences to be aware of for the AP exam. The backslash quotation mark escape sequence allows us to add quotation marks to a string value. If we didn't use an escape sequence, then Java would think we're using quotation mark to end the string. Using the double backslash escape sequence allows us to place backslashes in our string text. This is similar to the last example. Just like quotation mark, backslash usually has a special meaning. In this case, backslash is used to start an escape sequence, while if we don't want to start an escape sequence and just want a backslash in our string, then we'll use double backslash. We're using an escape sequence to say that we don't want backslash to be interpreted as the start of an escape sequence. It's a little mind-bending. Finally, if we place a backslash n escape sequence in a string, the compiler will output a new line of text. Gotcha. So, create a variable called opening lyrics that has a value of yesterday. Yesterday, all my troubles seem so far away. Such a good song. I'm pretty sure it's a Beatles song, but I think about it as a Marvin Gaye song. Call system.out.println to print out opening lyrics. Static checking. The Java programming language has static typing. Java programs will not compile if a variable is assigned a value of an incorrect type. This is a bug, specifically a type declaration bug. Bugs are dangerous. They cause our code to crash or produce incorrect results. Static typing helps because bugs are caught during programming rather than during execution of the code. The program will not compile if the declared type of the variable does not match the type of the assigned value. Int greeting equals hello world. The string hello world cannot be held in a variable of type int. For the example above, we see an error in the console at compilation. Error incompatible types. String cannot be converted to int. Int greeting equals hello world. When bugs are not caught at compilation, they interrupt execution of the code by causing runtime errors. The program will crash. Java's static typing helps programmers avoid runtime errors and thus have much safer code that is free from bugs. In the mess.java file, we have declared a bunch of variables with the wrong type. Try to compile the file using the command javac mess.java. Change the types of the variables. So they correspond with the type of the assignment values. So compile the file again. Look at how it compiles with no errors now. Naming. Let's imagine we're storing a user's name for their profile. Which code example do you think is better? String data equals Delilah or string name of user equals Delilah? While both of these will compile, the second example is much easier to understand. Readers of the code will know the purpose of the value Delilah. Naming variables according to convention leads to clear, readable, and maintainable code. When someone else or our future self reads the code, there is no confusion about the purpose of a variable. In Java, variable names are case sensitive. My height is a different variable from my height. The length of a variable name is unlimited, but we should keep it concise while keeping the meaning clear. A variable starts with a valid letter or a $sign or an underscore. No other symbols or numbers can begin a variable name. First place and asterisk gazer are not valid variable names. Variable names of only one word are spelled in all lowercase letters. Variable names of more than one word have the first letter lowercase, while the beginning letter of each subsequent word is capitalized. This style of capitalization is called camel case. In the badnames.java file, we declared variables with confusing names. Run the file and look at the error messages you get when trying to compile. Some of these variable names are illegal. Change the ones that are preventing the file from compiling. So, first name .com. Is that it? Review. Creating and filling variables is a powerful concept that allows us to keep track of all kinds of data in our program. In this lesson, we learned how to create and print several different data types in Java, which you'll use as you create bigger and more complex programs. We covered int, which stores whole numbers, double, which stores bigger whole numbers and decimal numbers, boolean, which stores true and false, char, which stores single characters using single quotes, string, which stores multiple characters using double quotes, static typing, which is one of the safety features of Java, variable naming conventions. Practice declaring variables and assigning values to make sure you have a solid foundation for learning more complicated and exciting Java concepts. The file myprofile.java contains a class that represents your hiring profile as presented to potential employers. In the main method, create a variable called name. So create a variable called age. Create a variable called desired salary. Desired salary. You already know what it is. Boom. Per year to a precision of 2 decimal points. Define. Oh, well, that's why I'm not making the big desired salary, isn't it? Create a variable called gender that holds a single character. M, F, N, or O. Create a variable called looking for job that holds whether or not you are currently open to job offers. I'm always looking, always on the hunt for a better opportunity, or an opportunity. What's up next? Which of the following lines would throw a compilation error? String grades on test A, int balance equals -30, double is raining equals false, char grade on test was F. So what line of code declares a variable called numRabbits to store a whole number? What value cannot be assigned to a variable with the data type double? What is the value of num? So 4 plus 3 is 7, 10 minus 7 is 3, 3 times 6 is 18, so num is 18. Which option is a valid variable name and follows the Java naming conventions? Which option is a valid variable name and follows the Java naming conventions? Cool. What data type can only be assigned one of two values? Which line declares the variable best programming language and initializes it to be Java? So string best programming language equals Java. Which of the following values is a valid char? Cool. So just setting the tone. I'm not doing any of these projects. As I said at the beginning, I'm already taking my second semester of Java. It's just that my teacher, I barely learned anything. Last semester I got an A because I just, I did what it took, right? But I didn't learn the fundamentals properly, in my opinion. Not as well as in my C++ classes, not as well as taking Python courses on here. So that's why I'm doing this. Before I get into this section, I'm gonna go heat up some more coffee though. So I'll be right back. Good. We're good. Cool. So, introduction. Let's say we are writing a program that represents a user's bank account. With variables, we know how to store balance. We'd use a double, a primitive type that can hold big decimal numbers, but how would we deposit and withdraw from the account? Lucky for us, we have the ability to manipulate the value of our variables. We can use expressions, arithmetic operators, and more in order to change our variables' values. For example, Java has built-in arithmetic operations that perform calculations on numeric values. In the final line of code above, we see the expression balance plus deposit amount to determine the new value. The data type, so when executed produces a single value, the data type of a variable plays a large role in the operations we can use to manipulate it. We can think of data types as a combination of a set of values and a set of operations on those values. For example, the double data type is comprised of values like 4.8 and operations like addition. For now, we'll mainly focus on the set of operations that can be used on numbers and booleans. The data type of an expression is determined by the resulting value. For example, an expression that uses two int values will evaluate to an int value. If an expression contains a double value, then the resulting value will also be typed double. Throughout this lesson, we will learn how to manipulate variables of different data types. In the file guessinggame.java, we have defined two integers, mystery1 and mystery2. Use system.out.println to print the variable that holds a value of 2. In our bank account example from the last exercise, we use the plus operator to add the values balance and deposit amount. If we wanted to withdraw from the balance, we would use the minus operator. Alright, this is simple enough. And then there's the increment and decrement operators. Create an int variable called animals and zoo that holds the amount of zebras plus the amount of giraffes. then print it off. You know, I know nobody's watching this right now, but leave a comment if you think this is a big waste of time, or if you think it's smart to master the fundamentals in several different languages over a short time period. I think it's actually been pretty beneficial. So, but two of the zebras have been traded to a neighboring rival zoo. Subtract 2 from the number of zebras and store the result in a variable called num zebras after trade. I remember the first time I took a coding class, or just even read a coding book or took a coding course online. Zebras in zoo -2. Then print it. I was like, it can't be this. Like, what? Give me the real stuff, you know? What is these console logs and assignments and arithmetic operations? This is not what powers the internet, but it really is. It's pretty crazy. Multiplication and division. Gotcha. So division has different results with integers. I guess I'll read. Multiplication is simple enough. If we want to see how many hours our total balance represents, we use the division operator, / division has different results with integers. The / operator does integer division, which means that any remainder is lost. Evenly divided stores what you expect, but unevenly divided holds 2 because ints cannot store decimals. It's important to note that the int doesn't round the decimal, but floors it. Java removes 0.5 to fit the result into an int type. It's important to note that if we try to divide any number by 0, we will get an arithmetic exception error as a result. In main, there's a variable called subtotal, which represents the subtotal of an amount to pay on a bill, and a variable called tax, which represents the tax rate that will be applied to that subtotal. Create a double variable total that holds subtotal plus the product of subtotal and tax. Print the total variable. There were 4 people who brought this meal together and want to split the cost. Create a double variable called per person. That holds total divided by 4, and then print or system out that print line per person. Modulo. If we baked 10 cookies and gave them out in batches of 3, how many would we have left over after giving out the full batches we could? The modulo operator % gives us the remainder after 2 numbers are divided. You have 1 cookie left over after giving out all the batches of 3 you could. Modulo can be a tricky concept, so let's try another example. Imagine we need to know whether a number is even or odd. An even number is divisible by 2. Modulo can help. Dividing an even number by 2 will have a remainder of 0. Dividing an odd number by 2 will have a remainder of 1. You are trying to split up students into groups of 3. How many students will be left out once the groups are made? Create a variable called left out. That holds the modulo of students and 3. Then print it. Compound assignment operators. Sometimes we need to adjust the value of a variable. Imagine we're working at a bake sale and want to keep track of how many cupcakes we have by creating a variable called num cupcakes. If we baked 8 more cupcakes, we know that we could update our variable using the plus operator. While this method works just fine, we had to write our variable num cupcakes twice. We can shorten this syntax by using a compound assignment operator. Compound assignment operators perform an arithmetic operation on a variable and then reassigns its value. Using the plus equals compound assignment operator, we can rewrite our previous code like so. Num cupcakes plus equals 8. Now we only need to reference num cupcakes once. We can use compound assignment operators for all of the arithmetic operators we've covered. You are also in charge of keeping track of how many cookies there are at the bake sale. This value is represented by the variable num cookies. A customer comes and buys 3 cookies. Or I don't have to redeclare it. Use the appropriate compound assignment operator. So minus equals 3. Another customer buys half of the remaining cookies. Use the appropriate compound assignment operator to reflect this change. Order of operations. If we were to place multiple operators in a single expression, what operation would the compiler evaluate first? The order of operations dictates the order in which an expression like the one above is evaluated. Operators that share the same precedence are evaluated from left to right within the expression. The order is as follows: parentheses, exponent, modulo slash multiplication slash division, addition slash subtraction. With this new information in mind, let's dissect the expression from above so that we can find the value of num. 5 times, so 10 minus 4, and then 5 times 6, and 4 divided by 2. Or, so 10 minus 4 would be evaluated first because it is wrapped in parentheses. This value would become 6, making our expression look like this. Next, 5 times 6 will be evaluated because of the asterisk operator. This value is 30. Our expression now looks like this. Following the order of operations, 4 divided by 2 will be evaluated next because the division operator has higher precedence than the addition operator. Our expression now resembles the following: 30 plus 2 is 32, so the value of num is 32. Take a look at the expressions in operations.java. Solve for the value of each of the expressions on your own to find out if your calculations are right. Uncomment the print statements and run the code. I'm not going to do that. PEMDAS, it's simple enough. It's fine. Greater than and less than. Cool. Print the expression that checks if the amount of credits you have earned. Credits earned is greater than the number of credits you need to graduate. Credits to graduate. So we need to check if the amount of credits earned is greater than the number of credits you need to graduate. False. Create a variable called credits after seminar. Credits should be the sum of credits earned plus credits for seminar. Print out whether credits to graduate is less than credits after seminar. True. Equals and not equals. Copy. You have unearthed 2 unlabeled albums, record A and record B. To see if these are the same album, you're going to compare the number of songs on each one and the total length of the albums. First, create a variable called same number of songs that stores whether 2 albums have the same number of songs. Now, now create a variable called different length that stores the result of checking whether 2 album lengths are not the same. greater than, less than, or equal to. You have been trying to complete a 30-day challenge to drink enough water per day. It's a reminder. Create a double variable called total recommended amount. And set it to the product of the recommended water intake and the amount of days in the challenge. Create a Boolean variable called is challenge complete. And set it to the result of checking if your water intake is at least as much as the total recommended amount. Didn't print it. False. Damn. Gotta drink more water. Dot equals. So far, we've only been using operations on primitive types. Doesn't make much sense to multiply strings or see if one string is less than the other. But what if we had two users logging into a site and we wanted to see if their usernames were the same? With objects such as strings, we can't use the primitive equality operator. To test equality with objects, we use a built-in method called dot equals. When comparing objects, make sure to always use dot equals. Equality operator will work occasionally, but the reason why it sometimes works has to do with how objects are stored in memory. For the purposes of this lesson, as well as good practice, remember to use dot equals instead of the equality operator when comparing objects. To use it, we call it on one string by using dot and pass in the string to compare against in parentheses. So if we have string person 1, Paul, string person 2, John, string person 3, Paul, system.out.println person 1 dot equals person 2 will print false, and system.out.println person 1 dot equals person 3 will print true. We have 3 lines from a song in song.java. First, print out whether line 1 and line 2 are the same. Line 1 dot equals line 2. String concatenation. We have covered a lot of built-in functionality in Java throughout this lesson. We've seen plus, minus, less than, equal to, and many other operators. Most of these only work on primitives, but some work on strings too. Let's say we want to print out a variable and we want to describe it as we print it out. For our bank account example, imagine we want to tell the user your username is username with the value of the variable username displayed. The plus operator, which we used for adding numbers together, can be used to concatenate strings. In other words, we can use it to join 2 strings together. String username equals prints Nelson. System.out.println your username is plus username. This code will print your username is prints Nelson. We can even use a primitive data type as the second variable to concatenate, and Java will intelligently make it a string first. So int balance equals 10,000. String message equals your balance is plus balance. System.out.println message. This code will print your balance is 10,000. In our zoo, we have a certain number of animals stored in animals of a certain species, stored in species. Use plus to make a new string variable called zoo description. It should hold a string that looks like so. I see. Final keyword. Throughout this lesson, we've discussed the different ways we can manipulate a variable. However, what do we do with a variable that should never change its value? For example, the year we were born will always stay the same. There's no way we can change that information. A value like this in our code should be unchangeable. To declare a variable with a value that cannot be manipulated, we need to use the final keyword. To use the final keyword, prepend final to a variable declaration like so. Final int year born equals 1968. When we declare a variable using final, the value cannot be changed. Any attempts at doing so will cause an error to occur. Error cannot assign a value to final variable year born. Create an unchangeable double variable called pi. .14. On a new line, try to change the value of pi. And we will get an error. Review. What's the use of having variables if you can't do anything with them? We've now seen some ways you can operate on variables and compare them. The possibilities are endless. We covered addition and subtraction using plus and minus, multiplication and division using asterisk and forward slash, the modulo operator for finding remainders, percent, compound assignment operators, the order of operations, greater than and less than, equal to and not equal to, greater than or equal to and less than or equal to, equals method for comparing strings and other objects, using plus to concatenate strings, the final keyword which makes variables unchangeable. Practice some of these concepts here to make sure you have a solid foundation for learning more complicated and exciting Java concepts. To review, let's try building some of the bank account functionality we talked about throughout the lesson. First, create a new double variable called updated balance. Store balance minus amount to withdraw. Now you've decided to split your balance evenly 3 ways and give it to your 3 best friends. Create a double variable called amount for each friend. Your friends each want to buy a concert ticket with the money you've given them. The tickets cost $250. Create a boolean called can purchase ticket. And set it equal to whether or not amount for each friend is at least enough to purchase a concert ticket. So how much money did you give your friends anyway? Use plus and system.out.println to print out. Nice. The expression 5 is not equal to 6 will evaluate to true. To what value does the following string concatenation evaluate? It's plus 5 plus PM. It's 5 PM. True or false, the value of a variable declared with the final keyword can be changed. False. What is the best way to tell if the following 2 strings are equal? Username 1 dot equals username 2. How could we get a result of 10 given the following variable? Double A equals 2, A times 5. Are there any errors in this Java statement? Int status equals yes, int should be boolean. After the following code is run, what value will the variable endpoint be assigned to? Int variable equals 11 modulo 3. so it'll be 2. What does the following code do? System.out.print line 8 is less than or equal to 8. It prints true. What will the following program output? Int num equals 12. Num times equals 2, so 24. Minus equals 4, so 20, so 21. Which operator can be used to concatenate 2 strings? Nice. I refuse to do these projects. Classes and objects. Where are we at in the syllabus right now? Object-oriented Java. Okay. Big leagues, big leagues. So let me bring the audio in to a reasonable level, because I know my voice is kind of quiet. This is probably not going to sound too reasonable, but regardless.
Hey, my name is Mike. I'm a developer from Philadelphia, and in this video, I'm going to give you an introduction into object-oriented programming by answering the question, what are classes and objects? So without further ado, let's get into it, and we'll learn about these two really important concepts. One of the best things about writing programs is being able to easily work with and keep track of different types of data. In fact, data is the driving force behind most programs that you'll write. And programs are constantly parsing strings, adding and subtracting numbers, counting things, and passing different pieces of data around. In all major applications, being able to work with data in an organized and structured way is extremely important. Now, by default, most programming languages will allow you to store and keep track of 3 distinct types of data: text, numbers, and Boolean values. And with these 3 data types, we can represent all different types of information, things like people's names with text, whether or not someone is an organ donor with a Boolean value, or the price of an item with a number. And being able to keep track of simple pieces of data like this is really great. But what happens when we need to work with more complex data? We can represent a name with a string and a price with a number, but what if we want to represent something more complex like an entity in the real world? Let's take a student, for example. Imagine we're writing a program for a school and we wanted to keep track of the students who are currently enrolled. So now instead of keeping track of names with strings or prices with numbers, we want to be able to keep track of students. But the problem is we don't have a data type for students. There's no student data type floating around that's built into the language like strings, numbers, or booleans. On top of that, we might also want to define some functionality around the student, like giving school administrators the ability to mark a student as absent or change their grades, for example. And as we write more and more complex programs like the one for this school, we'll want to be able to keep track of and model more complex pieces of data, and therefore we need more complex data types. In order to solve this problem, we can use an object-oriented programming language. An object-oriented programming language is a programming language which allows developers to create their own custom data types. So even if the language doesn't provide a student data type by default, a developer could create the student data type and then use it just like they would a normal string, number, or Boolean value. So if we use an object-oriented programming language to write our school program, we can easily keep track of all of the students by creating a custom student data type. So how exactly does this work? How can we go about creating our student data type and start creating students in our program? The first step is to create a student class. In object-oriented programming, a class is a specification of the new data type. It's essentially a blueprint that tells the programming language what the new data type looks like and what it's made up of. In our student class, we can define the attributes and the functionality that make up a student by creating a student class. The attributes of a class are individual strings, numbers, or booleans, which define the attributes of the entity we're modeling. In this case, a student might have a name attribute, which would be a string, a GPA attribute, which would be a number, a year attribute for freshman, sophomore, junior, or senior, that might also be a string, and then maybe a has scholarship boolean, which would determine whether or not the student has a scholarship. So you can see we can define all these different attributes of a student, which themselves would be either strings, numbers, or booleans. In addition to attributes, we can also define functionality around the student. So for example, we might create a has honors function inside of the student class, which would use the GPA of the student to determine if they qualify for honors. So maybe if the student has a GPA of greater than 3.5, then we would say they have honors. Or we could create a give scholarship function, which would set the has scholarship boolean to true, thus giving the student a scholarship. And so the class can have these attributes and these functions, which will essentially make up the data type and allow us to define what a student looks like in our program. When we create a class, we tell the language what this new data type looks like and what it does, but all we're doing here is describing the data type. We're not actually creating a student that we can work with. To create a student in our program, we'll need an object. An object is an instance of a class, which means a student object would be an instance of our student class. So a student object is an actual student with an actual name, GPA, year, and scholarship status. So in our program, we might create 3 student objects with names Jack, Kate, and Sawyer, and each of them would be an instance of our student class. Now the object is the actual thing that we're going to work with in our programs. You could pass it around, you can store it inside of a variable, you can access each one of those attributes or call any of those functions. The object is the implementation of the class. The class is just simply the blueprint. It defines what the new data type looks like. Now the cool thing about classes and objects is that once we define what the data type looks like in the class, we can create as many objects or instances of that class as we want. So our program can keep track of thousands of student objects, all with their own name, GPA, year, etc. Now our code could also use the functions exposed by each of these student objects to, for example, give them scholarships or figure out if they have honors. So if some other piece of code was responsible for granting scholarships to students, it could use the give scholarship function for a particular student in order to do that. So object-oriented programming is really great because it allows us to model real-world entities like students in our programs. So we can create a student class and then create instances of that student class, student objects, and use them. Now you can do the same thing with other entities in the real world. It doesn't just have to be students. You can model a light bulb, you can model a microphone, you can model an animal or a day of the week. You can model anything that you can think of. And object-oriented programming is great because it allows you to be flexible enough to model just about anything in the real world. So that's a little bit about object-oriented programming. It's an extremely popular way to write programs, and most of the modern programming languages support it. Thanks for watching. I hope you enjoyed the video and you learned something new. I'll see you next time.
Did I learn something new? Did I enjoy the video? No and yes. I like the animations. Introduction to classes. Okay. This probably feels like avoidant at this point. And yeah, to some extent it is. But I'm gonna go get some more coffee. But it also helps me just, stay fresh. Come back, you get up, you sit down. It's like, it's a reset. Also, today's just one of those days. A lot of these days have been one of these days. It just feels a little hard, I guess I'm just being a baby. Whatever. It's not that hard. What am I doing? I'm doing beginner coding courses. It's not that hard. But I think to some extent, that's what kind of makes it hard, Like when there's a daunting deadline to accomplish, it's easier to just get focused and stay in the zone. When something's difficult versus when something's a little easy, it's easier to feel tired and tune out and not to have that pressure on you. But anyway, I'll take a sip. It's funny, when I'm in the moment in the morning, so, I usually don't eat until some point in the early afternoon. And so the first part of my day is like coffee, and I'm hungry and I want to eat food. And the second part of my day is food, and I kind of just want to chill and drink coffee. But if I were to do either in their inappropriate time, it would throw off the balance, throw off my energy levels. I think there's an allegory there for the work thing that I just mentioned too. We want what we can't have. And then when we have something, we sort of want its opposite. I'll find myself later in the day, maybe getting a whiff of my empty coffee cup and wishing I could drink a coffee at 6 p.m. and it not keep me up. Right now I don't feel too hungry, but it's about 10. I'll feel pretty hungry in about 2 hours. But I'll just have to power through. Question is, can I get through this introduction to classes in about an hour and a half, which is the time I have left? Probably not. And a piece of me is feeling like this is a waste of time, but you know what definitely is a waste of time is continuing to sit here talking instead of learning. So let's get into it. All programs require one or more classes that act as a model for the world. For example, a program to track student test scores might have student, course, and grade classes. Our real-world concerns, students and their grades, are inside the program as classes. We represent each student as an instance or object of the student class. This is object-oriented programming because programs are built around objects and their interactions. An object contains state and behavior. So we have fields, state, and methods, behavior. Classes are a blueprint for objects. Blueprints detail the general structure. For example, all students have an ID, all courses can enroll a student, etc. An instance is the thing itself. This student has an ID of 42. This course enrolled that student, etc. Let's review another example, a savings account at a bank. What should a savings account know? The balance of money available. What should a savings account do? Deposit money, withdraw money. So we have methods for the behavior, which are withdraw and deposit. We have fields for the state, which is balance Savings account as software object. Imagine two people have accounts that are instances of the savings account class. They share behavior, how they deposit and withdraw, but have individual state, their balances, and even with the same balance amount, these accounts are separate entities. Our text editor contains a complete class definition that will build up as we progress through the lesson. Run the code to see it in action. Our first shop sells lemonade at 99 cents per unit. Our second shop has 12 units remaining. Classes syntax. The fundamental concept of object-oriented programming is the class. A class is the set of instructions that describe how an instance can behave and what information it contains. Java has predefined classes such as system, which we've used in logging text to our screen, but we also need to write our own classes for the custom needs of a program. Here's a definition of a Java class. Public class car. Scope of car class starts after curly brace. Public static void main string args. Scope of main starts after curly brace. Public program tasks. Scope of main ends after curly brace. Scope of car ends after curly brace. This example defines a class named car. Public is an access level modifier that allows other classes to interact with this class. For now, all classes will be public. This class is a main method which lists the tasks performed by the program. Main runs when we execute the compiled car class file. In the code editor, create a public store class. Your program will not compile without a main method. Define one within store. Constructors. In order to create an object, an instance of a class, we need a constructor method. The constructor is defined within the class. Let's take a look at the car class with a constructor. The constructor car shares the same name as the class. So public class car, constructor method public car, instructions for creating a car instance, and then public static void main string args, body of main method. To create an instance, we need to call or invoke the constructor within main. The following example assigns a car instance to the variable Ferrari. So we have our constructor car with instructions for creating a car instance, and then we invoke the constructor car Ferrari equals new car. In this example, instead of being declared with a primitive data type like int or a boolean, our variable Ferrari is declared as a reference data type. This means that the value of our variable is a reference to an instance's memory address. During its declaration, the class name is used as the variable's type. In this case, the type is car. After the assignment operator equals, we invoke the constructor method car and use the keyword new to indicate that we're creating an instance. Omitting new causes an error. If we were to output the value of Ferrari, we would see its memory address, car at 76 ED at that number. Keep reading. AP Computer Science A students. We can initialize a reference type variable without assigning it a reference if we utilize the special value null. Something that is null has no value. If we were to assign null to an object, it would have a void reference. For example, in the following code snippet, we'll create an instance of car, assign it a reference, and then change its value to null. So car Thunderbird equals new car. System.out.println Thunderbird will print its location. Thunderbird equals null, change value to null. System.out.println Thunderbird will print null. It's important to note that if we use a null reference to call a method or access an instance variable, we will receive a null pointer exception error. Again, if we use a null reference to call a method or access an instance variable, we will receive a null pointer exception error. Let's explore how code execution moves around the file with two methods. Add a print statement inside our store constructor with the message I am inside the constructor method. We'll see this message whenever we create an instance of store by calling the constructor. We did not see our constructor message printed because we haven't run the code inside the constructor. Inside main, create an instance of store called lemonade stand. Lemonade stand. And we see the constructor method. Inside main, print lemonade stand to see how Java represents this instance. Review the order of the printed messages. Running the program invokes main, start of the main method. We create an instance, so we move from main to store. I am inside the constructor method. The code inside store runs. When store finishes execution, we return to the main, and then this runs store at that memory location. Classes, instance fields. Our last exercise ended with printing an instance of store, which looked something like that. The first part, store, refers to the class, and the second part refers to the instance's location in the computer's memory. We don't care about memory location, but our instances have no other characteristics. When an object is created, the constructor sets the initial state of the object. The state is made up of associated data that represents the characteristics of an object. We'll add data to an object by introducing instance variables or instance fields. We want car instances of different colors, so we declare a string color instance field. Oftentimes, instance variables are described as has a relationship with the object. For example, a car has a color. Another way to think of this is that instance variables are the nouns and adjectives associated with an object. What qualities other than color might a car have? Miles per gallon, year made, and so on. So public class car, declare fields inside the class by specifying the type and name, string color. Public car, instance fields available in scope of constructor method. Public static void main string args, body of main method. The declaration is within the class. The declaration is within the class, and the instance variable will be available for assignment inside the constructor. Fields are a type of state each instance will possess. One instance may have red as its color, another blue, etc. It's the job of the constructor to give these instance fields initial value. We'll learn how to do this in the next exercise. Add some state to our store class. Declare a string instance field for product type. Classes, constructor parameters. To create objects with dynamic individual states, we'll use a combination of the constructor method and instance fields. In order to assign a value to an instance variable, we need to alter our constructor method to include parameters so that it can access the data we want to assign to an instance. We've already seen a parameter in the main method, string args, but this is the first time we're using the parameter value within a method body. The car constructor now has a parameter, string car color. So public class car, string color, constructor method with parameter, public car, string car color, parameter value assigned to the field, color equals car color, public static void main string args, program tasks. When a string value gets passed into car, it is assigned to the parameter car color. Then inside the constructor, car color will be assigned as the value to the instance variable color. Our method also has a signature which defines the name and parameters of the method. In the above example, the signature is car, string car color. In the next exercise, we'll learn how to pass values into a method. Keep reading. There are two types of parameters, formal and actual. A formal parameter specifies the type and name of data that can be passed into a method. In our example above, string car color is a formal parameter. Car color will represent whatever string value is passed into the constructor. We'll learn about actual parameters in the next exercise. In Java, because of constructor overloading, a class can have multiple constructors as long as they have different parameter values. The signature is useful in that it helps the compiler differentiate between the different methods. For example, public class car, string color, int mpg, boolean is electric, constructor 1, public car, string car color, int miles per gallon, color equals car color, mpg equals miles per gallon, constructor 2, public car, boolean electric car, int miles per gallon, is electric equals electric car, mpg equals miles per gallon. In the example above, there are two constructors. When we initialize an object, the compiler will know which constructor to use because of the values we pass into it. For example, car, my car equals new car, true 40, will be created by the second constructor because the arguments match the type and order of the second constructor's signature. If we do not define a constructor, The Java compiler will generate a default constructor that contains no arguments and assigns the object default values. Default values can be created by assigning values to the instance fields during their declaration. Public class car, string color equals red, boolean is electric equals false, int cup holder equals 4, public static void main string args, car my car equals new car, system.out.print line my car.color prints red. Add the string parameter product to the store constructor. Oops. So inside of the constructor method, set the instance variable product type to the product parameter. Classes assigning values to instance fields. Now that our constructor has a parameter, we must pass values into the method call. These values are referred to as arguments. Once they are passed in, they will be used to give the instance field's initial value. Here we create an instance Ferrari in the main method with red as its color field. Public class car string color, public car string car color, assign parameter value to instance field, color equals car color, public static void main string args, parameter value supplied when calling constructor, car Ferrari equals new car red. We pass the string value red to our constructor method called new car red. The type of the value given to the invocation must match the type declared by the parameter. Inside the constructor, the parameter car color refers to the value passed in during the invocation red. This value is assigned to the instance field color. Color has already been declared, so we don't specify the type during assignment. The object Ferrari holds the state of color as an instance field, referencing the value red. We access the value of this field with the dot operator. Accessing field, object name dot field name, Ferrari dot color, red. An actual parameter or argument refers to the value being passed during a method call. Call by value is the process of calling a method with an argument value. When an argument is passed, the formal parameter is initialized with a copy of the argument value. For example, when we declared the Ferrari object, the string value red is passed as an argument, then the formal parameter car color is assigned a copy of that value. Inside main, create an instance of store and assign it to the variable lemonade stand. Print the instance field product type from lemonade stand. Classes multiple fields. Objects are not limited to a single instance field. We can declare as many fields as are necessary for the requirements of our program. Let's change car instances so they have multiple fields. We'll add a boolean is running that indicates the car engine is on, and int velocity that indicates the speed at which the car is traveling. So public class car string color, boolean is running, int velocity, new parameters that correspond to the new field. So public car string car color, boolean car running, int miles per hour, color equals car color, is running equals car running, velocity equals miles per hour, public static void main string args, new values passed into the method call, car Ferrari equals new car red true 27, car Renault equals new car blue false 70, system.out.println Renault is running, system.out.println Ferrari velocity. The constructor now has multiple parameters to receive values for the new fields. We still specify the type as well as the name for each parameter. Ordering matters. We must pass values into the constructor invocation in the same order that they're listed in the parameters. Values match types, no error. Car Honda equals new car green false 0. Values do not match types, error. Car Junker equals new car true 42 brown. Add 2 new instance fields for store. Inventory count of type int. Inventory inventory price of type double. Update the store constructor method with the new parameters. In the body of the store constructor, assign the parameter values to the appropriate instance fields. Inside main, create an instance of store called Cookie Shop. Cookie Shop has cookies as the product. Cookie Shop has 12 cookies to sell, and each cookie costs $3.75. I'm gonna take you to the cookie shop. Classes review. Java is an object-oriented programming language where every program has at least one class. Programs are often built from many classes and objects, which are the instances of a class. Classes define the state and behavior of their instances. Behavior comes from methods defined in the class. State comes from instance fields declared inside the class. Classes are modeled on the real-world things we want to represent in our program. Later, we will explore how a program can be made from multiple classes. For now, our programs are a single class. So we see public class dog breed with an instance field of string breed, a constructor method public dog string breed, value of parameter dog breed assigned to instance field breed. So breed equals dog breed, public static void main string args, create new instance, use new operator and invoke constructor, dog Fido equals new dog poodle. Fields are accessed using the instance name, dot operator, and the field name. System.out.println Fido.breed prints poodle. The text editor contains a dog class. Play around with the code. Try to add and remove instance fields. Create instances with different values. Access and print different fields. I get it though, so I'm going to keep pushing. Instances of a Java class represent the real world with what two qualities? State and behavior. An instance is declared in the main function. Complete the method call. So window, bedroom window, new window, boolean, int, and an int. So true. What is the signature of the following constructor? String bug name, boolean can fly, int num legs. The following class definition requires a parameter to be passed into the constructor in order to make an instance. The bank class has one instance field, branch location count. Complete the constructor method for this class. So int num locations. The main method is automatically run when the class file is executed. True. Why will the following program produce an error? So public class shelf, string material, public shelf, public static void main string args, shelf bureau equals new shelf pine. No constructor method has been declared. The instance field has an incorrect declaration. The constructor does not have a parameter listed. Every Java program contains at least one class. Complete the following class definition for a bank class. Public class bank. What is the data type of the variable Hedwig? So public class owl, string speak, boolean nocturnal, public owl speak equals hoot, nocturnal equals true, public static void main string args, owl Hedwig equals new owl. And it's asking what is the data type of the variable Hedwig is an owl. Cool. Methods. Alright, as usual, be right back. as I sip this coffee, I you know, this is I don't really care about plugging myself or anything, but I started reading this book yesterday, Cybernetics by Norbert Wiener, and I just can't help but think about it. If you want to check out me reading it, you can check out the video, I think, before this. But just I recommend the book in general. I guess I can't recommend the book yet because I've only read the introduction, but it's coloring the way that I'm thinking about coding right now, just in terms of how our virtual world, digital world, I'm not sure which term I prefer to use, but it's these classes, it's these methods, everything has a state, and the transfer of data to all of these objects changes their state and just defines all the logic of the way that you hear my voice, the way that you see me, the things on my screen. And the book was written in 1947 or 1948, and it blows my mind to think that this stuff is less than a century old. You know, humans have been around for millions of years. We've had written, recorded history for, let's say, at least thousands of years. And yet we've only been doing this type of stuff, like this type of stuff, for less than 100 years. At the level that it is currently. I don't know when the microphone was invented or when the camera was invented, but relatively speaking, it's about a century old, I believe. It just blows my mind, the acceleration, the evolution. It really does blow like it's insane. And that's the one thing I fluctuate between deciding, like, do I really care about living a long time or possibly living hundreds of years or whatever it might be. Who knows where science is going to take us. But if I look at what life was like, you know, I was born in 1998. To think about a person being born in being born in 1898, and had they lived to see today's world, they'd be 125. It seems possible that if an individual were to play all of their cards ideally, there's a chance they could live to that old with some like reasonable level of health and their wits about them. I don't know, because I haven't really dug into the whole longevity thing, but it just makes me wonder, would it be worth it to stick around to see what the world is like in 100 years? I don't know. My philosophy of life is that life has a lot of suffering and a lot of pain, but all of it is inherently beautiful. Even if it doesn't feel like it from the first person, from the third person it is. So I think being here is better than not being here, but it's just hard to imagine what the world will look like at that point to be confident to say whether living an extra 20 to 40 years is worth the sacrifice it takes on a daily basis. I lean towards yes, but I don't make that sacrifice, you know. I eat a lot of meat. I'm not a vegetarian. It seems like that's the best bet in terms of longevity. Other than that, I think I do some things decently well. But regardless, let me get back to this. So, learn Java methods, introduction. In the last lesson, we learned that objects have state and behavior. We have seen how to give objects state through instance fields. Now we're going to learn how to create object behavior using methods. Remember our example of a savings account. Savings account has a field, state, balance, and methods for behavior, withdraw, and deposit. The state tells us what a savings account should know, the balance of money available. The behavior tells us what tasks a savings account should be able to perform. Depositing, increasing the amount available; withdrawing, decreasing the amount available; checking the balance, displaying the amount available. Methods are repeatable, modular blocks of code used to accomplish specific tasks. We have the ability to define our own methods that will take input, do something with it, and return the kind of output we want. Looking at the example above, recreating a savings account is no easy task. How can one program tackle such a large problem? This is where methods with their ability to accomplish smaller, specific tasks come in handy. Through method decomposition, we can use methods to break down a large problem into smaller, more manageable problems. Methods are also reusable. Imagine we wrote a sandwich making program that used 20 lines of code to make a single sandwich. Our program would become very long very quickly if we were making multiple sandwiches. By creating a make sandwich method, we can make a sandwich anytime simply by calling it. In this lesson, we'll learn how to create and call our very own methods inside of our programs. If we were to share this sandwich making program with another person, they wouldn't have to understand how make sandwich worked. If we wrote our program well, all they would need to know is that if they called make sandwich, they would receive a sandwich. This concept is known as procedural abstraction, knowing what a method does, but not how it accomplishes it. We have made a savings account class without using any methods beyond main and the constructor savings account. Run the code to see some account behavior happen. Look at the main method. It's so long. There is so much repeated code. Can you imagine how messy it would look if you needed to make 10 deposits? So for example, to make one deposit, int after deposit equals savings.balance plus 600, savings.balance equals after deposit, system.out.println use deposited plus 600. Throughout this lesson, we will learn how to make methods that would make checking the balance, depositing, and withdrawing all behavior that would take only one line of code. Defining methods. If we were to define a check balance method for the savings account example we talked about earlier, it would look like the following. Public void check balance, system.out.println hello, system.out.println your balance is plus balance. The first line, public void check balance, is the method declaration. It gives the program some information about the method. Public means that other classes can access this method. We will learn more about that later in the course. The void keyword means that there is no specific output from the method. We will see methods that are not void later in this lesson, but for now, all of our methods will be void. Check balance is the name of the method. Every method has its own unique method signature, which is composed of the method's name and its parameter type. In this example, the method signature is check balance. The two print statements are inside the body of the method, which is defined by the curly braces. Anything we can do in our main method, we can do in other methods. All of the Java tools you know, like the math and comparison operators, can be used to make interesting and useful methods. Check balance is considered a non-static method because its signature does not include the keyword static like the main method does. We'll learn more about non-static methods later in this course. In between the constructor and the main method, add a method called advertise to the store class. What is it returning? It should be accessible by other classes and should have no output. You can leave the body of the method empty. Inside the advertise method, type two print statements. They should result in the printouts. Come spend some money. So does it actually want to see the it seems like they actually want to see the quotation marks. spend some money. Where product type is replaced with a value in the variable product type. However, we're not going to see these strings printed out yet. We'll see in the next exercise how we can make these printouts actually run. Calling methods. When we add a non-static method to a class, it becomes available to use on an object of that class. In order to have our methods get executed, we must call the method on the object we created. Let's add a non-static start engine method to our car class from the previous lesson. Inside the main method, we'll call start engine on the myFastCar object. So class car, string color, public car, string car color, color equals car color, public void start engine, system.out.println, starting the car, system.out.println room, public static void main string args, car myFastCar equals new car red, call a method on an object, myFastCar dot start engine, system.out.println, that was one fast car. Let's take a closer look at the method call, myFastCar.startEngine. First, we reference our object myFastCar, then we use the dot operator, period, to call the method startEngine. Note that we must include parentheses after our method name in order to call it. If we run the above program, we will get the following output. Starting the car, vroom, that was one fast car. Code generally runs in a top-down order, where code execution starts at the top of a program and ends at the bottom of a program. However, methods are ignored by the compiler unless they are being called. When a method is called, the compiler executes every statement contained within the method. Once all method instructions are executed, the top-down order of execution continues. This is why starting the car and vroom were outputted before that was one fast car. Last exercise, we defined a new method advertise, but we didn't actually see it run. We now have a store class with advertise defined. Call the advertise method on the lemonade stand object in the main method and see what the output is. Lemonade stand dot advertise. Now call the advertise method on the lemonade stand object 2 more times. It should be called in the main method 3 times total. Scope. A method is a task that an object of a class performs. We mark the domain of this task using curly braces. Everything inside the curly braces is part of the task. This domain is called the scope of a method. We can't access variables that are declared inside a method in code that is outside the scope of that method. Looking at the car class again, class car, string color, int miles driven, public car, string car color, color equals car color, miles driven equals 0, public void drive, string message equals miles driven plus miles driven, system.out.println message, public static void main string args, car myFastCar equals new car red, myFastCar.drive. The variable message is declared and initialized inside of drive, cannot be used inside of main. It only exists within the scope of drive. However, miles driven, which is declared at the top of the class, can be used inside all methods in the class since it is in the scope of the whole class. Inside of the advertise method, change the product type variable to the cookie variable. Which is declared in the main method. This should also result in the printout selling cookies. Right? No, we got an error. The cookie variable cannot be accessed inside of the advertise method. The scope is wrong. Change it back to product type. Inside of the main method, print the string message, which is declared in the advertise method. This should print selling cookies, right? Foiled again. The message variable only exists inside the scope of the advertise method. Delete the faulty print statement from the main method. Adding parameters. We saw how method scope prevents us from using variables declared in one method in another method. What if we had some information in one method that we needed to pass into another method? Similar to how we added parameters to constructors, we can customize all other methods to accept parameters. For example, in the following code, we create a start radio method that accepts a double parameter, station num, and a string parameter called station name. Class car, string color, public car, string car color, color equals car color, public void start radio, double station num, string station name, system.out.println, turning on the radio 2 plus station num, comma, station name, exclamation mark, system.out.println, enjoy, public static void main string args, car my car equals new car red, my car dot start radio 103.7, meditation station. Adding parameter values impacts our method signature. Like constructor signatures, the method signature includes the method name as well as the parameter types of the method. The signature of the above method is start radio double string. In the main method, we call the start radio method on the myCar object and provide a double argument of 103.7 and string argument of meditation station, resulting in the following output. Note that when we call on a method with multiple parameters, the arguments given in the call must be placed in the same order as the parameters appear in the signature. If the argument types do not match the parameter types, we'll receive an error. Through method overloading, our Java programs can contain multiple methods with the same name as long as each method's parameter list is unique. For example, we can recreate our above program to contain two start radio methods, where one takes a double station num and a string station name, and the other takes just a double station num. Add a method to the store class called greetCustomer. It should be accessible by other classes and return no output. Accessible by other classes and return no output. For now, have it take no parameters and leave the body of the method empty. Modify the greetCustomer method so that it accepts a string parameter called customer. Inside of the greetCustomer method, add a print statement to print inside the main method, call the greetCustomer method on the lemonade stand object. Pass in a string argument of your choice. Welcome to the store, friend. Reassigning instance fields. Earlier, we thought about a savings account as a type of object we could represent in Java. Two of the methods we need are depositing and withdrawing. So we have public class savings account double balance, public savings account double starting balance, balance equals starting balance, public void deposit double amount to deposit, add amount to deposit to the balance, public void withdraw double amount to withdraw, subtract amount to withdraw from the balance, public static void main string args. These methods would change the value of the variable balance. We can reassign balance to be a new value by using our assignment operator equals again. So public void deposit double amount to deposit, double updated balance equals balance plus amount to deposit, balance equals updated balance. Now when we call deposit, it should change the value of the instance field balance. So public static void main string args, savings account my account equals new savings account 2000, system.out.println my account.balance, my account.deposit 100, and then system.out.println my account.balance. This code first prints 2000, the initial value of my account.balance, and then prints 2100, which is the value of my account.balance after the deposit method is run. Changing instance fields is how we change the state of an object and make our objects more flexible and realistic. We've added a price instance field to the store class. However, to combat inflation costs, We found ourselves increasing the price of our product over and over. We've added an empty increase price method to the store class. It takes a double parameter price to add. Inside of the increase price method, create a variable called new price. Declare it to be a double and set it equal to the price plus the price to add. Inside of increase price, set the instance field price to be new price. In the main method, increase the price of the lemonade stand by 1.5. Then print the lemonade stand price. Cool. Returns. Remember, variables can only exist in the scope that they were declared in. We can use a value outside of the method it was created in if we return it from the method. We return a value by using the keyword return. So public int number of tires, int tires equals 4, return tires. This method called number of tires returns 4. Once the return statement is executed, the compiler exits the function. Any code that exists after the return statement in a function is ignored. In past exercises, when creating new methods, we use the keyword void. Here we are replacing void with int to signify that the return type is an int. The void keyword, which means completely empty, indicates that no value is returned after calling that method. A non-void method like number of tires returns a value when it is called. We can use data type keywords such as int, char, etc. to specify the type of value the method should return. The return value's type must match the return type of the method. If the return expression is compatible with the return type, a copy of that value gets returned in a process known as return by value. Unlike void methods, non-void methods can be used as either a variable value or as part of an expression like so. Public static void main string args, car my car equals new car red, int num tires equals my car dot number of tires. Within main, we call the number of tires method on my car. Since the method returns an int value of 4, we store the value in an integer variable name called numTires. If we printed numTires, we would see 4. We learned how to return primitive values from a method, but what if we wanted our method to return an object? Returning an object works a little differently than returning a primitive value. When we return a primitive value, a copy of the value is returned. However, when we return an object, we return a reference to the object instead of a copy of it. Let's create a second class carLot that takes in a car as a parameter and contains a method which returns a car object. So class carLot, car in lot, public carLot, car, given car in lot equals given car. So this is a constructor of carLot which takes in a car object called given car and assigns the given car to this car in lot value. And then a public car return a car, so a method to return a car object, return car object, return the car in lot. If we do public static void main string args and create a new car, my car equals new car red 70, system.out.println my car, and then carLot my carLot equals new carLot with my car, system.out.println my carLot.return a car. This code outputs the same memory address because my car and car in lot have the same reference value. We want to have a method that returns the price plus tax. Define a method called getPrice with tax that is intended to return the price plus the tax. It should take in no parameters and return a double. You can leave the body of the method empty for now. Inside the getPrice with tax method, create a double variable, total price, that is equal to price plus price times 0.08. Inside of main, set a double variable lemonade price to the value returned by lemonade stand dot get price with tax. then print what I do wrong. Double lemonade price equals lemonade stand dot get price with tax. The two-string method. When we print out objects, we often see a string that is not very helpful in determining what the object represents. In the last lesson, we saw that when we printed our store objects, we would see output like that. When store is the name of the object and that number or that string is its position in memory. This doesn't tell us anything about what the store sells, the price, or the other instance fields we've defined. We can add a method to our classes that makes this printout more descriptive. When we define a two-string method for a class, we can return a string that will print when we print the object. So if we do class car, string color, public car string car color, color equals car color, public static void main string args, car my car equals new car, red, system.out.println my car, public string to string, return this is a plus color plus car. When this runs, the command system.out.println my car will print this is a red car, which tells us about the object my car. In the main method, print the objects lemonade stand and cookie shop. Are these printouts helpful? Not really. Create a two-string method for the store class. The method signature should say that it is public and that it returns a string. Shouldn't take in any parameters for now. How to return the string store. Store isn't very helpful. What kind of store is it? Change the two-string to return a string that describes this store object. Your string should look like this. This store sells product type at a price of price. Look at the printouts again. Are they more helpful now? Yes, they are. Review. Great work. Methods are a powerful way to abstract tasks away and make them repeatable. They allow us to define behavior for classes so that the objects we create can do the things we expect them to. Let's review everything we've learned about methods so far. Defining a method. Method declarations will declare a method's return type, name, and parameters. Calling a method. Methods are invoked with a period and parentheses. Parameters. Inputs to the method and their types are declared in parentheses in the method signature. Changing instance fields. Methods can be used to change the value of an instance field. Scope. Variables only exist within the domain that they are created in. Return. The type of the variables that will be output are declared in the method declaration. As you move through more Java material, it will be helpful to frame the tasks you create in terms of methods. This will help you think about what inputs you might need and what output you expect. Now that we've learned about behavior, we can apply behavior to our savings account class using methods. We've added the functionality for each method inside main now, but you will be rebuilding each above main. Note that your methods can directly access the balance field. First, write a method called check balance that prints that the balance of the account displayed should take no parameters and return nothing. method called deposit that takes in an int parameter amount to deposit and adds it to the balance. It should return nothing. Now write a method called withdraw that takes in an int parameter amount to withdraw and subtracts it from the balance. It should return the amount to withdraw. Test out your methods by trying to replace some of the code in the main method with the equivalent methods. Make sure to use check balance, deposit, and withdraw at least once each. So instead of this, we'll just do savings dot check balance. We'll do savings dot withdraw 300. We'll do savings dot deposit 500. And congratulations, you made a basic savings account. If you want, you could add more functionality to this. What other instance fields might you want to keep track of? What might a toString look like for this class? So that's pretty much my time. Do they have a quiz for me to take? Let's find out what's next. Which method signature would make a method that returns an int and takes in a string? So returns an int. It's going to be this and takes in a string. Which line of code is not an example of calling a method? I didn't even try. In this method definition, what does miles represent? Public void run int miles, a parameter of type int. Is there an error that will prevent this code from running? Class coffee, public coffee, public void stir. Oh, string stirring equals stirring the coffee. Public static void main string args. Coffee my cup equals new coffee. My cup dot stir. So if you do my cup dot stir, it just creates this string called stirring. And then if you do system.out.println stirring, yes, the variable stirring cannot be accessed in the main method. When defining a method, the void keyword specifies which of the following method returns default Java errors. The method does not return a value. Fill in the code that will call the add sugar method with 7 as an input. So int sugar cubes. So add, what is it called? My cup dot add sugar 7. An object named Dalmatian belongs to the spot class, which of the following correctly calls the run method on Dalmatian. So the object is called Dalmatian. So it'll be Dalmatian.run. Cool. Not gonna do it. Have enough project work going on in school to do these projects. I'm not doing all that. But I just want to get to a clean cutoff point. Another one. Interesting. Okay, control flow seems like a good place to leave it to the next one. Made decent progress. Probably gonna take me like 2 more of these to get through this, and then maybe 1 or 2 more to do the intermediate. So within the week I'll be done with this, and then I'll have about 3 weeks to do my final project. Seems worthwhile, so for right now I'm good.